Hello and welcome. Today I decided to give a short overview of how to work with JSON format in Clojure. So this will be most useful for beginners, I believe, and who are just starting using Clojure and have to use JSON responses and all that stuff. But maybe not just for beginners. Maybe you'll find something useful, some hidden feature of the libraries. So yeah, let's jump in. First of all, why JSON? Because it's the most common format that we use in our real world right now. So yeah, of course, there are some drawbacks in JSON. You cannot represent some certain data types. You don't have sets. You don't have bunch of things. But the idea is that it's so commonly used, and any language have any kind of library to work with JSON. So if you expose your APIs and use JSON as a format, your consumers, your clients will be happy because they'll be able to just read that data. And yeah, also the other use cases, we have JSON. Sometimes in Kafka topics, we have JSON files, we have JSON payloads in our Postgres databases, so plenty of use cases for the format. Regarding Clojure, there are a couple libraries to mention, and we're going to take a look into two today. So one is Cheshire, which was the most popular JSON library in Clojure for a long time, and more recent one, although it's been multiple years since it was written, is JSonista, and we'll take a look into APIs of both libraries and what we can do with them. And also I'll share a link to this post, which is quite nice overview of JSON ecosystem in Clojure. They're talking about multiple libraries, again, covering Cheshire and JSonista, but also there is a set of libraries called something like data.json, data.xml, and all that stuff. So the thing to mention about this library is that it has 0 dependencies. So if we check project CLJ and we check dependencies, we only see Clojure. So if that's something that you need, like to keep your dependencies list as small as possible, and you don't care too much about JSON encoding, decoding performance, so maybe this will be a good option for you. I never used this library in production services, unfortunately, and I know it is significantly slower than the other two options that we're going to cover today. But I don't have any benchmarks available to prove that. So yeah, but yeah, we'll talk about what's used in day-to-day work. So yeah, I'll share the link in the description as well. Cool. So let's jump into the code. So I created a small project, and basically we have these dependencies. We have Cheshire, we have JSonista, and we'll use this handy library as well to convert different casing for our property names. So let's see, let's jump into the Cheshire namespace. I created 2 namespaces, one for Cheshire, one for JSonista, to showcase the features. Also, if we go and grab some JSON from here, so just some random JSON, and if you use a cursive and if you open quotes and if you insert your JSON, it will automatically escape these symbols like quotes and add new lines and all that stuff. If your editor doesn't support that, you can always use an online tool if you want, and if you click on JSON escape, it will give you the same representation. So basically it's a string that contains valid JSON inside. So that's it. Now let's work with this data, what we can do. And the simplest API is just to decode that into Clojure structures. So it will look something like JSON decode. And as you see, I require a Cheshire core as JSON. And then we provide our JSON string. And that's it for now. If I execute that, you see we get now a Clojure data structure. And we can work with that. So it's basically like a map. It has items like count, next item, and then we have result, and the result is actually an array of maps. So yeah, that's good. Now we can work with that as data. So that's the beauty of Clojure. So it is kind of like when you work with data that's represented by JSON, you have similar experience as you work with JSON in JavaScript, where it's like a native format, right? Compared to Java, when you have to work with JSON, you basically pass your JSON, but after that you have some objects and you need to define all that. So here we are in a good state when we have just data and we can manipulate that now. The bad thing now is that these keys in our map are just strings, so it's a bit more annoying to work with. So for example, if I have this block and if I want to get count, I need now to go and do get count. So how we can fix that is if we go inside and check the pass string, there is a second property here called KeyFN, and we can pass any key there, any function there to convert our keys in our output. That could be any function. You can implement it yourself. A useful option to know is that it could take value true, which means convert our keys to keywords. To demonstrate that, let's just try doing that. So we have true, and we now execute once again. Oh wait, sorry, not true. True boolean. Okay, and now it looks much better, right? But as you can see, sometimes in JSON we have snake casing, so it will be things like ABC underscore whatever. Sometimes we have camel case, so it will be something like money field, things like that. So there is no one agreed convention how you should name your keys in JSON. In Clojure, we usually use kebab case, which is like this, something like that. So to convert that to our Clojure-friendly look, we need to provide a separate function here, a specific one to convert our casing. It could be really annoying to write it yourself because there's too much formats and all that stuff, but luckily there is a library exists, and we use that quite a lot in a lot of use cases. So it allows you to convert any casing. So you basically say convert any casing to this specific one. So to demonstrate that, let's just try to use that. And for example, we want, as we're going to our Clojure code, we can do to kebab case keyword. And if I now run that, you see this was converted into a keyword. So the list is actually huge, so you can check yourself. It's all different casing that's supported. And if we try something crazy, maybe like camel snake keyword, that's now our keywords. And it's actually supporting any format in the original JSON. So for example, if we had, where is our next? Give me a sec. So we have our next, let's say it will be next item, but also we have, let's say first name, but it's in camel case. You could think that it's crazy and an API response cannot contain keys with different casing. The hard truth is that I've seen real production APIs that mix the casing. So sometimes it's useful to know how to handle that. So now let's say that we want our Clojure format. So we want kebab case keyword. And if I execute that, wait a sec. If I execute that, we now have everything correctly named. So that's all about decoding. Actually, one more thing. It's a bit of niche use case, but by default, if you use numbers like that with a point, like a float or double, it will convert it to a double. By default, yeah. Sorry, I had like a running REPL, so that's why it's already fixed. But yeah, if we do false here, and you see now we have the double as the result of decoding this simple value. And it is false by default. So if you do nothing, your strings like this will be converted to double. Sometimes, especially if you have something like money types or something like that, you want to use big decimal. And to override that, you unfortunately have to tweak this dynamic var from inside the library. So it says dynamic here, and the naming convention is like this. Use big decimals. It is in Cheshire parse namespace. So if you do alt var root and you set it to true, now the type of this should be big decimal, right? Yeah, see. Right, so that's about decoding from string. But now let's say we have our JSON and we want to convert it back to a string. So now it's encode, and the first argument will be our JSON. If we run that, we will see our ugly string representing JSON. So again, the casing is not converted. So to fix that, we now provide this KeyFN. Note that we have now the difference in API. So in decode, it was just a separate argument. In encode, this will be a map representing different options. So yeah, just to my taste, a bit of a flaw in library API, but yeah, it is what it is. So for KeyFN, let's say we want use camel cases. And now if we run that, we see that our next item is like that, and also we should have first name somewhere, or URL link. Yeah, URL link. And the other option that's available is to do pretty printing. So we do pretty true. And now the result looks like this. So yeah, that's all about Cheshire. As I said, it's widely used in Clojure X system. It is used in CLJ HTTP, or I mean, like, you can enable an option that CLJ HTTP will try to decode your JSON responses for you. You just provide this library as dependency and enable an option. And yeah, some ring middleware, use Cheshire, and all that things. So that's a decent option. And from what I've seen, it's still a mix of Cheshire and the other library which we're going to cover next. Let's move to JSonista. We'll do almost same exercise. So we have this JSON input at the top, and after that we use now JSonista as the require, and let's do JSON read value. So it's different API here. It was decode, now it's like read value. And if we just do JSON input and just execute that, you see similar thing like this. Difference now is that to configure different options, you have the second argument and it's consistent. So you provide this object mapper in the read value function, but also the same object mapper into write value function. Write value function will be our encode function in this library. So to create an object mapper, there is a function. So if we just do JSON object mapper, it will create a default one. So as you can see, it's from this library, from Jackson. And boom. And there is also JSON default object mapper. It's not a function, it's a default object mapper. It's basically just call of the object mapper here. And this is used by default. So if we want something custom, we need to get this object mapper and put it as the last argument here. And now we can configure that. So it has nice documentation of all properties in one place. So as we're doing decoding now, we want to use this DecodeFN and this big decimal property. So let's say we want set DecodeFN to be same thing like to kebab case keyword. It should be a map like this. Let's execute. Yeah, now we have our correct naming for the fields. And again, just briefly show you for the big decimals. Let's just simplify it to 10, 1, and do type on top. So now we have double, and if I provide the property for big decimals true. Now we have big decimal. So compared to Cheshire, it's already a win from my point of view. So there is no global configuration even for these tiny things like that. You have your object mapper that always passed as an parameter to your function. So it is more like functional approach to my taste. So that's good. Moving next is reading values, writing values, right? So let's get our result as our input, and we do JSON write value as string. Then we have our value, and we can try to execute that. So we have some string here. You see, nothing converted. And now we can try to configure that to our taste. So let's pick this JSON mapper as starting point. And we want encodefn to be under, let's say, snake case. So we have something different, snake case string. Let's go. And now it's converted to underscores here. After that, we can try order by keys, true. And that will sort our keys inside the map. How we can test that? If I say this is a result or something, let's see if that works. Yeah, so now this is the first entry in the map. So it's not necessary to use that, obviously, but a nice option to know about. And then we have stripped nils. Let's see if we have any nils here. So yeah, for previous, you see this, we have null. Sometimes you just want to drop the key that contains nil. So let's see if this option will help us. Strip nils, true. Yep, now we don't see that. And I believe you can put the nil in any place. So if we just do it somewhere deeply inside, so like an optional field. Now we have one here, and we should see the field, yeah. And if we do nil, it should be removed from the array as well. Yeah, looks good. And of course the pretty printing, same thing, pretty true. Yeah, now we have something like that. So you obviously don't have to define this object mapper always when you do a decode or encode. The common pattern is that you have your, like, for example, my service JSON object mapper, and it could be different. For example, one JSON object mapper for things when you read stuff from your files, one for your database, one for Kafka, one for HTTP requests. If you have different requirements, different formats, you can create different mappers. And now we just get this bit, we put it here, and now we can just use it when we call the function. Everywhere, like this, and this, and oh wait. Yeah. That. And that should still work. Yeah. And also, if you have your service where you define your object mappers, you can create like your functions to read value or something like that, and you can just accept value and then delegate JSON read to JSonista. Then you have value, and then you have your my service JSON mapper, and in that case you just do read value here, and you don't need your object mapper, something like that. Cool. So I think that's it for today. I hope you now have a good understanding of the libraries, how to work with JSON. Hope that was useful. Please don't forget to like, subscribe, and leave comments. And also there are ways to support my channel or by buying me a coffee. So follow the links if you want to support the channel. Have a nice day and see you next video. Bye bye.